help?
I'm upgrading a router at the moment. When it finishes upgrading, I'll see.
It's one. Sorry?
I don't think I've ever met Renee.
Really?
Yeah.
Oh, wow. I'll copy the
Yep.
agenda.
Yes, I sent them. Yeah, I should get the chain kit.
You're right. I must have been first percent. I just didn't recognize it. I must have been at first percent.
I think he's only ever presented here remotely before, so you may not have seen him because he was just up on the screen. Who knows?
I can do the chair slides if you want. If you want to hand me the clicker.
And when you get put in this jail,
Were you using the Wi-Fi?
I was using the Wi-Fi, but I had to be on my corporate VPN because the way the corporation.
So you were exiting and get people for the rest of the corporation.
But it's not just me, I know it's killing me.
So you have any from Cascade? You wouldn't hide yet? You were not the only one.
This particular one that I see.
All right.
Most.
I think we've given people their minutes grace for returning from lunch. All right. Yes. And there's a blue sheet that you can sign in on if you missed the. I think we may actually want to circulate that. Glenn, could you grab that and start circulating it?
Don't write your name on it.
Yeah, you don't need to write your name on it, but you do need to scan it with your badge so that we get an accurate sense of how many people are actually in this meeting for planning purposes. All right. So welcome everybody to the MOPS working group meeting. I'm Leslie Daigle, co-chair Kyle Rose, and tech advisor Glenn Dean now sharing the blue sheets for people who want to scan in. Is there a lag? Or is there somewhere I'm supposed to point it? Can I point it at you?
Oh, you know what it is? I have to have that tab
Open. Yep.
in focus.
All right. This is the note well and appreciating that we are already on day 2 of the IETF meeting. You've probably heard this a billion times already, but you should still note well, please, that you've agreed to, by participating, you've agreed to follow IETF processes and in particular the IPR policies, and also in terms of the agreement to work respectfully with other participants. And if you feel that you've had any challenges in this working group or anywhere else in the context of working in the IETF, you are welcome to contact the ombuds people who will be happy to help work out any issues and would certainly care to hear from you. Okay, so we've said please make sure to sign in. Thank you for signing in so we get an accurate count. We will be using Medico for the managing the queue. So I will be, or Kyle will be calling out names from the queue, and you don't want to wind up standing lonely at the microphone, not being called on. So please do use the Medico tool. I did copy this slide from the last meeting, so I apparently neglected to take out the wear masks unless actively speaking at the microphone. So we can have a moment of appreciation for the fact that we have moved on enough from the COVID pandemic that we are back to being our usual joyful selves.
I think Yokohama might also be in the next slide.
I tried to get that.
I
Oh,
forgot
well.
to ask you for the slides to fix it.
Sorry. All right. Yeah. Yeah, there you go. IETF 17 Yokohama is news to many people, I'm sure. But you can still.
I don't feel so bad about my working group slides later on because I think I did the same thing.
I'm sure I can update these before we make the meeting minutes. But anyway, yes, the point is the business end of this slide is still valid. These are the pointers to where you can get the agenda, Meet Echo and other information and reporting issues. All right. So this is our agenda, which you will have seen circulated on the mailing list, I'm sure. And I would take this opportunity to thank Lenny very much for being our scribe. But he is taking all offers of assistance in the shared hedge doc to keep the minutes up to date as we go along. So please do join him in the hedge doc to do that. I will also observe that he's got himself out from under being volunteered for another task for which we will be seeking volunteers during this session, which is to say we are going to be looking for a shepherd for preparing the AR document for submission to the ISG. So take that as an early warning. Any bashes to this agenda? All right. So I think we are all set to go over to Renan, if you would share his slides, please.
Hi, can you hear me?
Yes, we can.
Perfect. So hi, everyone. My name is Renan, and I will be presenting an update to our draft. This is a joint work with Akbar Rahman. Next slide, please.
I get it.
So the updates to the draft are in section 4 and section 5.2. We will talk about these changes in the next few slides. Next slide, please. In section 4 of the draft, we have removed the text discussing requirements for ABR algorithms as previously discussed in the working group. These requirements for ABR algorithms are out of scope for this draft as the intended audience for this document are network operators. These operators are interested in providing edge computing resources to operationalize the XR application use case, such as the one presented in this draft. On the other hand, the choice of ABR algorithm rests with the XR app developer. Next slide, please. Now in section 5.2, we have replaced the phrase expected end-to-end latency with required response time. We define response time as the time interval between the end of a request submission and the end of the corresponding response from a system. If the XR device offloads a task to an edge server, the response time of the server is the round trip time from when a data packet is sent from the XR device until a response is received. We note that the required response time provides an upper bound on the sum of the time taken by the computational tasks such as processing of scenes, generation of images, and the round trip time. The required response time depends only on the quality of service required by an application. This required response time is therefore independent of the underlying network technology and the time taken by the computational tasks. Next slide, please. So with the chair's permission, we'd like to ask the working group if the document is ready for a last call.
Thank you, Renan. In fact, we've launched a working group last call last week and are running it through Tuesday, 2 weeks from today is the time frame on that. So hopefully people have had a chance to begin reviewing it for the purposes of working group last call. And assuming that we have a positive outcome from the working group last call, we will be moving the document to send it to the ISG. So hence the request at this point for a volunteer to shepherd the document. So while you're pondering the value of that particular bit of experience, any questions or reflections on the document to discuss with Renan today? Or was this just the most convenient room to sit down and catch up on email? Well, I'm not hearing any questions or comments, and I think I'm going to interpret that as the document has shaped up nicely. Thank you, Raymond, for following it through the last few years. The working group last call indeed continues for another 2 weeks, as noted on the mailing list, but we won't be able to progress it any further than that without a document shepherd. So even if you're not willing to volunteer today, I would appreciate pointers to suggested people who might be useful for taking that task on, so that we can, in fact, progress the document. Okay. Must have been a good lunch. Food coma. All right. Thank you very much, Rainan.
Thank you.
This is like a whoopee cushion. Yes, yes, assuming that that I don't get distracted and
Go read your mail.
defocus the tab on my machine. So I'll try not to do that. So that would be embarrassing.
All right, so I'm going to give kind of a brief recap of TreatyN, what it is, why it is, what's the goals, and then an update from based on comments in the last meeting. So what is the motivation for TreatyN? The biggest thing is live audience sizes for events on the internet are there's an increasing number of events on the internet with massive audience sizes, and combine that with increasing bit rates for things like 4K and 8K and AR coming down the road. Are we at an inflection point for network resource utilization for these kinds of events and the stress and strain that it's putting on the network? Just some data points. Thursday Night Football last year was for the first time streamed exclusively on Amazon Prime, averaged about 10 to 15 million viewers, 3 hours a night, 15 nights a year. YouTube TV this season will carry exclusively NFL Sunday Night Ticket. Again, millions of the average NFL game has about 15 million viewers. And then the last month, maybe the month before, I think it was June, the cricket IPL final, they announced had 32 million concurrent streams. I believe that was a record. These are big numbers. And we could continue doing this with brute force unicast. It's worked reasonably well so far, but maybe there's a better way that's more efficient, that reduces costs dramatically for doing what is being done now, and also makes possible things that that maybe aren't quite so viable these days. Live streaming is not the same as on-demand streaming. The biggest difference is latency. The expectations, if you're watching a movie on Netflix, it doesn't matter if it's a minute or two later than, with a playout buffer that long. With a sporting event, the latency budget's about 10 seconds, because anything more than that, you have to worry about getting a text message from a friend about that amazing catch or the game-winning score, and you watch it 30 seconds later. You don't want that. You don't want to hear the bar across the street, people cheering and chanting, and you find out why a minute later. The other thing is join rates are vastly different for on-demand streaming. It's a typical diurnal pattern of it's expected, it's smooth, it jumps, but it jumps up predictably and smoothly. Whereas, when there's a game on, everybody's tuning in at the same time, right? And it's more of like a step function. So that's the kind of motivation and why we're proposing this architecture. What is the architecture? What are the components? It's TreatyN, which stands for tree-based CDNs. And the goal is to leverage the concepts of overlay networking as well as advances in the evolution of native multicast to deliver a service to end users regardless of where they are. They don't have to be on a multicast-enabled network in order to receive this multicast content. It's comprised of two components. The native component, we can call that on-net. That is the part of the network that is natively multicast enabled, and specifically uses SSM. ASM has officially been deprecated as an interdomain solution, and SSM vastly simpler and addresses the use case that we're most interested in here. And for the parts of the network that are not, for viewers who are sitting on unicast only networks, this is where overlay networking comes in, and specifically AMT. Some of the benefits here, incremental deployment. This is something that multicast has generally suffered from. So if you are multicast enabled, you enjoy the benefits, and if you are not, you just get tunneled over. The most important thing is the end users get the content. They are not dependent upon their last mile provider to offer them multicast in order to get this content. Did that
not try it again?
All right, there we go. Let me make sure I didn't go too far. Okay. All right, so diving in a little deeper, the components, like I mentioned, the native part uses SSM. Why SSM? It's vastly simpler, and it solves one of the fundamental problems of internet multicast, which is it's too complex. We hate it. You know, it's too difficult. With SSM, you know, you eliminate about 90% of the complexity of multicast. In terms of protocols, typically PIM SSM, but it doesn't have to be. It could be anything that delivers the SSM service model. So you could do MLDP, GTM, even BGP, MVPN, BEER, TreeSID, you name it. Anything that can deliver multicast natively in an SSM manner, you can use it. Like I said, PIM SSM is the most common deployment, but and then there's the overlay component. And the purpose of the overlay is to dynamically build tunnels to the end host, or and it could be the host, it could be the application layer, or it could be a home gateway router, for example, that is multicast enabled. So you tunnel it to that, and it handles multicast within the home. Any of these things are possible, but the most important thing is AMT allows you to hop over the unicast only parts of the network. Typically, it's in a last mile, and it solves the fundamental last mile problem. Can also avoid things like you know, Wi-Fi and other in-home things that are not multicast friendly. This solves the other fundamental problems of multicast over the internet, the all or nothing problem, which is, you know, every layer 3 hop from source to receiver must be multicast enabled, otherwise it won't work. That's a really, really, really high bar, and getting everybody on the internet to run every router and firewall interface on the internet to run a routing protocol is really difficult. Just ask the V6 people. So AMT solves that. It just tunnels over, and it also solves the chicken and egg problem of there's no content because there's no audience, and there's no audience because there's no content. AMT is kind of the typical deployment, but it could use anything. You know, Lisp is an example of another tunneling technology. Any tunneling technology that could solve this problem could be used. AMT is kind of built for this use case, though, and it's kind of the most common deployment scenario. So here's kind of how it's going to look. You know, you can see you have a does this thing work? Oh, wow. So you have your content provider. This is your source. They're connected to the native component, the TreeDN provider network. And if you have local receivers, native receivers, they receive multicast the way God intended natively. And then if you have the more common scenario of, you know, the other 99% of the internet, which is unicast only. They just build AMT tunnels to the nearest AMT relay, and the content goes natively to the border and is sent via AMT to the end user, kind of tunneling over this unicast only network. So you may say to yourself, gee, isn't this what a CDN does? And really it is. I mean, what is a CDN? But it's you know, an efficient way of delivering content. And CDNs are basically doing multicast without doing multicast. I mean, they're essentially, if you look at most CDNs, and there's different CDN models, but if you take the typical model where you deploy, oops, wrong button. Okay. You deploy these CDN boxes, call them caches, call them whatever, right? And then you send the content to each of them, and then they handle local replication, right? And that's great. It's you know, it's just like multicast, except you know it works. You don't need everybody to run PIM on every router and firewall on the internet. But if you add multicast instead to this CDN, you gotta and this is what TreeDN is essentially doing. Let's rename those CDN boxes to AMT relays. And we will build an efficient native multicast tree to those relays. And then the relays will handle local replication. And you may say to yourself, well, what's the difference? Isn't this the same? So there's a couple nice benefits to this architecture over traditional unicast-based CDNs. The first point is we can move this replication point a bit closer to the end user because it can sit on let's say a peering router. And we're only sending the content to relays that have interested receivers. If you have no interested receivers here, you don't send the content to that relay. But the big benefit, and this is where you get your huge savings, is these relays aren't typically a CDN box is a rack of x86 servers. And you have to rack them and power them and cool them and plug them into routers. These relays are essentially as a function that is built into the forwarding plane of routers. So if you have a routing platform that supports AMT, essentially you can build a CDN on a chip, essentially zero cost, a couple lines of config in your router, you suddenly can offer CDN services. So if you have that hardware, you can offer these services at zero CapEx. And you can argue even perhaps zero OpEx because, you're not powering a bunch of new things and cooling a bunch of new things. So this is how you can deliver that same service at what's been called, an order of magnitude cheaper than existing CDNs today. All right, so the benefits, much more efficient network utilization. You can, like I said, it's been set, there's a network out there called UMETSAT, and they've said they essentially use this model. They're using their TreeDN provider, the Research and Education Networks, GIANT specifically, and they said that this model is an order of magnitude cheaper than using traditional unicast-based CDNs. Not only does it, and it also scales to support new content, not just making existing stuff cheaper, but also making possible new stuff, like say, for example, AR live streaming, right? Imagine you could put on some goggles and feel exactly what it's like to sit front row center court of a game and watch that game live. And imagine, hundreds of thousands or millions of people wanting to get such a high bandwidth experience. Can the internet do that today? We don't know if it can. It'd be really expensive. The other thing is, this is a much more sustainable, greener solution in that, again, you're eliminating the need for a bunch, racks and racks of devices because it's built into the forwarding plane of the network and the network infrastructure. It's enables service providers to offer new services, replication as a service. And again, if they have existing routing platforms that support this, they could do this at potentially zero cost. The other thing about this is, the difference is this is based on open standards-based architecture using widely deployed and widely available protocols, whereas CDN architectures tend to be proprietary and not quite so, interoperable. Also requires far less coordination between the content provider and the CDN. There's no storage. It's just forwarding packets. So if you don't have data storage, you don't have to protect that data. You don't have to worry about things like key management. All of that stuff is handled by the content provider and the end user. That's and the CDN is just pushing packets. It addresses some of the fundamental problems that network-based replication on the internet has had. Things like incremental deployment, overlay networking, solving the problem of multicast over Wi-Fi, other last mile challenges. It utilizes, an evolution of 20 to 25 years of advances in network-based replication technologies to eliminate a lot of the problems that have prevented multicast from being deployed over the internet. And the last thing is this is a decentralized, democratizing technology. Is it healthy for the internet and society that a small handful of companies kind of control nearly all distribution? This gets back to the decentralized vision for the internet, where anybody can start sourcing from anywhere if they're connected to the network and have that content be delivered cost effectively. Use cases and applicability. I've spoken mostly about live streaming because that's, the sexiest stuff there is, video, AR, telemetry, but it could be anything that needs to go multi-destination. So think large file software updates, right? Not very sexy, but operators will tell you this crushes networks when there's a new iOS update and everybody has to download, in the same day, this giant, multi-gig file. This is a much more efficient way of replicating that. All right, so that's the recap. That was for the people who, may have forgotten or haven't been paying attention. Now on to the updates. What did we add from the last draft to this draft since Yokohama? First, we added a pretty picture. Hopefully this is clearer in terms of how the pieces all fit together. That was one of the requests, that it wasn't clear from the draft. So any thoughts and feedback on this picture, if this is clear and makes sense, we'd welcome any feedback or any ideas to make it even better. And then the other, the biggest substantive change was we added a section, or we added to a section, basically the transport layer differences between TDN and traditional unicast-based CDN. So folks have rightly pointed out, well, CDNs work in a certain way, and there's things like reliability and billing and authorization and ABR, and a lot of these issues are less multicast versus unicast and really UDP versus TCP. So a lot of TCP is utilized today, and there are obvious benefits of TCP. But using UDP, it's in this with multicast, it's going to be much more scalable, and there are tools to address each of these things. So the purpose of this section is not to solve these problems. That's kind of outside the scope, but we're pointing out what our goal was, to point out these issues so that people are aware to deliver an end-to-end service. These are the things you need to consider, and pointers to where some of this work is being addressed. So things like reliability, FEC, norm, things like that have been used effectively. For ABR, we point to the MABR spec, which goes into great detail on how ABR can be achieved. Also, RFC 8085 covers this. The short answer, if you don't want to read either of these things, is one way you could do this is just have different bitrate streams on different multicast groups, and you can join and leave and work your way up and down depending on how well network conditions are working for you. Authorization and encryption, again with TCP-based unicast, you can ensure that and authorize each individual user. With multicast, the packets go everywhere, and you don't necessarily know who's getting them. So this is a consequence. This is no different than any other broadcast medium. I mean, a wireless area network is a wireless network has the same issues. When you send packets out, anybody could be getting those packets. So if you're concerned about who gets them, just encrypt them. And if unauthorized people are getting it, it's meaningless data because it's encrypted. So we point to some of the specs out there and prospective solutions that have been addressing encryption. And then just some minor textual questions. We renamed some sections, made it clear what is the problem statement. Okay, so next steps. We would love more review and feedback on the draft. Are there things that are not clear? We'd love to hear. And what else would the working group like to see? And that's it. I'll be happy to take
Any
further questions.
Kyle, did you put yourself in queue?
Oh. Do what I say, don't
Yeah.
whatever, right? Okay, Eric Ving, no head here. Do you have a plan to test it somewhere or make a proof of concept somewhere? Because that would be, I think, very interesting.
It is there. So you can check it out. Menu.treedn.net. You can see we have a live TreeDN network. We've over the last few years been developing that solution and talking about it in MBOND. And in fact, we have in the audience Bradley for his senior project added some enhancements to build a mobile app. So right now, if you go to menu.treedn.net, you can see a bunch of multicast streams that are available on the internet. It actually was developed by a student for her senior project, where she went to the looking glasses of Internet 2 and Giant, scraped through all the multicast content, and automatically, dynamically put them up on this menu is a portal, a listing of all the multicast content out there. Or folks who did have sources could list their sources, and you can click on them and launch them, and it'll launch VLC, an AMT capable VLC version, and you can receive it via AMT or via natively if you're on a multicast network. So this stuff is real. You can see it. This proof of concept has been going on for years. And actually, I mentioned UMetSat. They in, I believe it was London, presented with how they are working with Giant to do this. So you could think of Giant as one of the big TreeDN providers, and UMetSat is probably, the biggest user of this service. And what they are is they have satellites and they send atmospheric telemetry data. They stream it out, very high bandwidth real-time streams, and they send it out to research institutions across the globe. And they're the ones who said that, we use this instead of CDNs because it's, an order of magnitude cheaper. So this is real. It's happening. It's in use, and we welcome people checking it out.
All right.
It's a working code. Yeah.
Yeah, I'm going to give myself the floor. Kyle Rose, Akamai chair hat off. So this is great. As we, so Lenny and I had
lunch a couple of days ago. Maybe that was yesterday. Jeez. Anyway, and just to recap a little bit of what we talked about, I think the work that Jake and Max Franca and I were doing, like I needed to get some distance from that to get perspective on what you were trying to accomplish here. And it was some of my comments in my review, like maybe it might have been like a year ago now, were based on my perspective at the time about a very particular approach to the problem that I was trying to solve. Now that I have more distance from that, I can look at this work kind of from a different perspective that isn't that specific technical approach. And there's a lot here, and it's really promising. And I would say that, even if content providers have some reservations about, things like reliability or performance, or, like not having customers call them and say, like, why are like a few customers calling me and telling me that they're having problems viewing the stream. Even if they have those reservations, right? This is at a bare minimum. And I mean this as a positive statement. At a bare minimum, this is a demonstration of the viability of multicast for global interdomain delivery of video content, live video content. And so, I mean, I think it's great. I think this is really promising, and I would, and I think the draft that you've put together is, I mean, I would consider this, ready for last call or close to ready for last call. So, and I'll probably put together a more like a follow-up review based on the changes that you made. Again, not as, from the perspective of participant, not the perspective of a chair. But anyway, so I think this is great. Good work.
Thank you. Appreciate it. And I should say that section that we added on the transport issues, that is not our expertise. So please, those who do a review, we really would welcome more feedback on section 7. It's a short section, but if we're missing the mark, or if there's more relevant or better resources out there, please point us in the right direction. We are my co-authors and I are kind of, our specialty is layer 3, and we're attacking this at a network layer perspective, and the transport is a little bit outside of our wheelhouse, but we would definitely, there's a lot of experts who in this room that really understand that much better than us. So we would very much welcome that feedback.
Great, thank you. And I want to put in a couple of observations about sort of the room dynamics. A year ago, when you first presented here, there was a lot of enthusiasm and interest in adopting the document. So we did, thank you. And you just heard a couple of perspectives about, you've had the in-depth review of what this is and a couple of perspectives of where it fits in the universe. So if there are any other comments or questions now, or, do make sure to bookmark it and go and read the document and provide feedback on the mailing list. Because as Kyle's enthusiasm suggests, we'll probably be looking to at least working group last call this pretty soon. So any other thoughts before we let Lenny sit down? All right. Oh, can you put yourself in queue just so we can know who's where? Thank you.
Kenji, China Mobile. We have I think from the last July in Philadelphia and also in Oklahoma, we discussed the multicast source routing in order to handle a really large number of subscribers. So in that case, it's like way beyond the number that being discussed. So I'm not sure you have looked at that one, but look at this one if you're using like a 3D and those type of things. So I assume you are going to use subscriber-based replication toward the end side. Still, I try to think how your scheme can scale to such a large number. I can give you for one concert that happened last year in China, close to 100 million subscribers. 100 million more that goes through the multicast. So yeah. So I try to think about this one, and with the multicast source routing, we are proposing, try to see, okay, how this is going to work. Thank you.
Sure. Yeah, I mean, from a network perspective, I would say it should scale a lot better than unicast. From a data plane perspective, obviously there's control plane implications with numbers that large, but I mean that's what this architecture is designed to do, is to address these kinds of mass audiences. So if you do have pointers to that, be happy to look at the technical details and see if there are issues where this architecture falls short. But
it's in Philadelphia, MSR 6, I think SMR 6 BOF, and also Yokohama in the beer on Friday session.
That's okay. Sure. Overview. Yeah, and again, there's nothing in this architecture that we make no religious statements as to what components must or must not be used. Again, the native component, anything that can push multicast packets natively, whether it's beer or tree SID or MLDP or MSR v6, any of those technologies could be used to deliver the content. That's why this architecture, there's nothing really, there's no new ground, no new protocols. It's really the synthesis and putting together a bunch of existing protocols in a way that's maybe a bit novel, where you're combining a native plus an overlay. But yeah, I mean, it certainly should work just fine with any architecture you come up with. Any other questions? Okay, thank you.
Thank you very much, Lenny. All right. On to the SVTA update from Glendine.
Hi, I'm Glendine. Is this on? Can you hear me? Okay. Sorry, from where I'm standing right now. Oh, there it goes. I couldn't quite hear. So it sounded like I was just talking. Anyways, I'm Glendine from Comcast NBC Universal, and here I am giving the industry update, which I typically give at MOPS from this group. For those who aren't familiar with SVTA, it's a member organization of about 100 companies right now. And the best way to think of it, if you're familiar with Nanog, it's kind of like Nanog for video. So we take a lot of the technologies done in the IETF. You get a lot of operators, content providers, CDN people over at SVTA. We take those things, we deploy them operationally, but we also do things where we develop requirements, and we feed back into groups like the IETF. And if you're active in CDNI here, you already see a tremendous amount of stuff that comes back in from the SVTA as, wouldn't it be nice if CDNI did this? And requirements come in, CDNI does it, and then go back out to the SVTA. So it's a nice cycle going back and forth there. And if you are in this room and you're interested in video, there's a very good chance that your company is one of those 100 companies that are members today. And if you're not a member, Will Law, come see me and we will hook you up with whatever we need to do to make Will Law a member of the SVTA. I'm on the board and I can make it happen.
No sales pitches.
We also cover a lot of ground because, look, video is complex and there's a lot of technology that goes into delivering video at scale. So we do QoE, we do networking and transport, where we talk about things like DNS, we talk about multicast. We do open caching, we do metadata, we do security, we do privacy, we do a lot of that stuff. That's the important glue that takes the technology base that comes out of places like the IETF and turns it into a production environment that you can deliver video to the world at. Okay, so these are things of interest. I was trying to make connections between the two groups. So I mentioned CDNI, big connection point. We also are doing work on multicast and multi-CDN delivery. There's been some presentations done there. Quick is, of course, something that's interesting, and there's a quick POC going on right now in the SVTA. When we come to Prague, and this is the pitch to come see MOPS in Prague, I expect to come with a deck full of measurements and stuff of what we actually experienced in our POC in the SVTA around Quick. And the Quick POC there isn't to do a speed test to say HTTP 2 versus 3 or whatever. We're really building a reference environment for how to do those environment tests in your own production space, and then learn where you need to do better or different or make some choices. And one of the problems we had identified was that people didn't know how to assemble a quick test environment to test their environment to see how quick would work and how to tune it. So that's what we've done. We've done the reference implementation of the tests, and then we're going to get some initial results. I got some preliminary results, but they're not very robustly done. We're just starting to really expand the test suite right now and get more test data points collected. So come to Prague and we will give you that data. There's distributed tracing work being done, and there's a paper in the group I chair over the SVTA that's starting to work on the question of DNS and streaming. In other words, all the weird bad things you can possibly do in DNS documented in one place. Okay. In the fall of this year, the IETF is going to go to a lovely city called Prague. We've been there before, but there's something special about this visit. The SVTA will be there the days ahead of the IETF. So we're trying to put some things together, but right now, stay tuned. We're going to try to get the real as soon as possible. But if you're making travel plans and you want to come to see an SVTA meeting, come talk to me. I can probably get some guest invites. But we're going to be there Wednesday and Thursday in Prague ahead of the IETF. We're also going to try to arrange some joint activities here at the IETF. So things like hackathon stuff that overlaps between the two groups. We're going to try to do a bunch of hackathon projects. And on Sunday afternoon, we're trying to put together a essentially a video people interest group. It's not going to be an IETF meeting. It's going to be an SVTA meeting. It's going to be, are you interested in video and technology stuff? Come together and talk about that, how we can work together, what the priorities are, what the interests are. And right now, I'm sort of thinking it's going to probably be from 1 to 4 p.m., probably going to be at the IETF hotel on Sunday. So when you make your travel plans, don't show up on Sunday, come on Saturday, or even better, come a few days early, come to the SVTA meeting, take Friday off, do some touristy stuff around Prague. It's an awesome place. And then Saturday, go to the hackathon and get involved. The other thing we're going to do is we're going to ask the groups that have overlap at the IETF if they can move and request their time to be on the Monday, Tuesday agenda. That way, if you're an SVTA guy, you don't have to stay till Friday. Okay. If you want to know more, there's people you can talk to. You can talk to me. You can talk to Sanjay. Sanjay, put your hand up. You can talk to Chris Levins. You can talk to Ali Begin. And you can talk to Will Locke, because he actually has been at one of our meetings. And you can talk to Leslie. So, or you can talk to your member rep. Again, go to the svta.org website. We list all the member companies there. Your company may already be a member and you don't know it. Okay, and that's it. Any questions?
Chris?
You should check the dates for IETF and don't trust what was on the slide.
Did I put the wrong dates? November 1 and 2 are Wednesday and Thursday. Friday. Oh, I'm off by a day. You're right.
Yeah.
So sorry. I skipped Friday. Friday's the 3rd.
I checked. I'm pretty sure the SVTA dates are right.
Yeah.
And the hackathon and IETF dates are wrong.
Yeah. The November. So shift all those by one day. The 3 and 4 should be 4 and 5. Thank you, Chris, for catching that. Time is hard. Numbers are hard.
This time, Eric Vink, again, not following the chair advice to jump into the queue without putting myself into the queue. As the responsibility on this
What
one,
am I going to do?
please remind me 2-3 weeks before, remind me and Warren, 2-3 weeks before when we do the schedule of the meetings to put basically MOPS, maybe mock and quick on the Monday, Tuesday.
Okay. Perfect.
We are human beings, right? So I will forget.
Okay. Okay. Are there any questions? Like, any questions why we have a T in the name when we used to be called SVA? Why we became a SVTA? No? Okay. Well, then that's it. Close. It was actually trademark. But very close. It is an IP issue. Anyways, that's it. Thank you so much.
No, don't run away.
Will Loss, come into the
Yeah.
microphone.
Oh, hey, Glenn. This is great to see. One question, there was the legal revamp of SVTA. What is the status of that? Is it proceeded? The membership clause, which was stopping a lot of companies.
Oh, you mean the
joining,
IPR rules?
Yeah. What's the status?
Hang on, I'm working through what I can say. I can say that the board has a revised IPR set of rules that have been proposed, and they are reviewing them with counsel from the various companies that need to review these sorts of things, and we're hopeful that something soon will happen.
Awesome.
I'm feeling very, let me put it this way, without being detailed, I feel very positive.
Okay, it's good to hear. Thank you.
Okay, thank you.
All right. Thank you, Glenn. All right. So now we are at the AOB part of the meeting. So is there any other business? Anybody had a brainstorm and decided they wanted to stand up and be the shepherd for the AR document? Sanjay?
Not for the shepherd, Sanjay Mishra. I just wanted to ask a question to Will. Did you have any suggestion on any language for the IPR that, for example, Akamai would like to propose? So that might be a way to sort of hear what Akamai has to say about the IPR rules.
Well, that may not be an appropriate conversation for the
Yeah, I can respond. I'm an engineer. I should never ask me anything legal. And I can't actually comment, but I do know there was a review. So many of us at Akamai would like to join SVTA. There were issues with the IPR. Our legal team reviewed them, gave feedback back. We then heard from SVTA that they were revamping them, hence my question. So it's good to hear that there's progress, and we'll certainly be reviewing them once again when the new IPR conditions are released.
Great. Thank you. Chris, you're in queue.
I'm willing to have a conversation about what the document shepherd task entails.
Thank you. We will buttonhole you after the meeting. All right. I would like to make sure that everybody who is here has in fact signed in using the on-site tool or some other method of showing that you are here, so we can get an accurate count of the participation here. And absent any other business, I'll say thank you very much and see you in Prague.